Okay, we're going to look at permutations and combinations, mostly permutations first, because, well, we'll see. What is a permutation? What is a permutation? That's the first thing that we're going to look at. The definition of a permutation is very, very simple. It's just reordering of any number of objects. If you have like 4 objects, a permutation is just one of the ways that you can put those objects in order. If you switch the order around, it's a different permutation. So that's it. It's just reordering of certain objects, of different objects. That's it. To illustrate this, I can ask the question, what are all the permutations of ABC? Like, what are all the ways that I can reorder this? Now, I'm thinking like, well, hold on a minute. I know how to figure out the number of permutations, but writing out the permutations, that's a little bit different. So, first, I want to know what are the number of permutations? What are the number of ways I can reorder those? Well, since I have just 3 spots, A, B, and C, and I have different choices for those, like on this one, I'm picking from A, B, or C. I'm picking from those 3 letters. So in the first spot, I have 3 choices. In the second spot, I have 2 choices because I already used one of them. And in the last spot, I have 1 choice. So I have a total, if I multiply, a total of 6 possible permutations, 6 ways that I can reorder this. So if I'm able, I can write out all 6 just right now. In fact, I'm going to do that. Or maybe you should try to do it. Like one of the permutations would be simply ABC. That's easy. That's the first permutation, I guess, because that's the way it was presented. And then maybe ACB or BAC or BCA, or finally CAB and CBA. Those are all 6. That's it. There are 6. This is a permutation. This is a different permutation. This is a different permutation. It matters whether the order is the same or not. If you switch the order, that counts as a different permutation. That counts as another element. So hopefully that's clear. A lot of other math teachers will say, for permutations, order matters. And then they'll like leave it at that. And it's like, what do you mean order matters? What does that mean? Well, what it means is if you have a different order, it counts as a different thing. It's like, so ABC counts as something different than ACB. Whereas in some instances where maybe like you have a group of people and there's Alan, Betty, and Cynthia. If I have all 3 of those people in a group, this is still all the same people in a group. So if you have it's not called a permutation anymore, it's groups or combinations, but that's later on. So in that case, order doesn't matter, and if you change the order, it's still the same element. But in this case, when we consider permutations, like for license plates, if you switch the order of something, it's a completely different license plate. Or like phone numbers, if you switch the order of the numbers in a phone number, that's a completely different phone number. That's a permutation. So hopefully all of that makes sense, and we're going to look at some notation. There is a specific way to write, it's like a formula, actually, to write the number of permutations, and here it is. The number of permutations of n objects, say you have 5 objects, that would be n factorial. You say this is n factorial. So if I said how many different ways are there to rearrange 5 objects, you could say 5 factorial. But what does that mean? 5 factorial. What does a factorial mean? It just means take 5 and then start multiplying all the way down to 1. So 5 times 4 times 3 times 2 times 1. So you're just, it is 5. If you have n, or if n is 5, then 5 factorial, that's how you say this part, 5 factorial. All that is 5 times 4 times 3. If you had 11 factorial, all that would be is 11 times 10 times 9 times 8 times 7, all the way down to 1. And in this case, 5 factorial is 121. If I consider 8 factorial, that's just 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. It's just all the way down. And then you multiply those out. That's all the factorial means. That's it. That's all that there is. Except there's one special case, there's one rule, and that's 0 factorial. By definition, it is something. So by definition, 0 factorial is equal to 1. It's just 1. This is to help later on with stuff. You can start out formulas with 0, and then you don't have to actually do a special case. Just make a special definition. Anyway, I'm going to stop this video right there, and we'll get to some other notation in another video.